Okay, so welcome to chapter 3, and in this chapter we're going to get into doing some calculations on what they call measures of location, things such as means, median, mode, and talk about how you can use those to make some inferences. So think of this as kind of like the first chapter. We start to do some applied statistics, and notice even on the learning objectives we got the mean, median, mode. We have what's called a weighted mean. We're going to do a standard deviation calculation for both population and a sample. And very minimally, we're going to get into a little bit of the empirical rule, but really the empirical rule discussion is going to come when we get to, I believe it's chapter 7, is where we really get more involved with that. So don't stress too much because they don't really get into it a lot. And then the last thing we'll do is I'll show you how you can calculate a mean and a standard deviation for what they call group data. That's basically your frequency distributions when we get to there. So we've already done the frequency distributions from chapter 2, and in this chapter there's a calculation on how you can figure out what the standard deviation is of that group distribution. So like we said, the first thing we talk about is measures of location, and so we've got what's called the arithmetic mean, the median, and the mode, and in the next few slides we'll walk you through the basic calculations. Some of you probably already know some of this, but I'll still walk you through the formulas and how some of the symbols, how you should be reading some of the symbols, because that'll come into play later on when we get into some more longer formulas. Okay, so the textbook differentiates between what they call the population mean and the sample mean. And as you can see in this formula right here, you've got this symbol. I'm going to write this out again, and down below they kind of explain it, but that is pronounced mu, mu. And notice we've got the sigma there. That basically means to add, and then x is your observation, and then a capital N is going to represent a population. So depending on what you're looking at in terms of sampling or coming up with an average, they like to distinguish between the population and the sample by these symbols. So if you ever see this symbol right here, guys, that's going to be a population mean, which is pronounced mu. And so if this was our population, and notice our population in this case is 42 exits, and the data represents distance between exits, and you want to basically figure out what's the average number of miles between exits, what you simply do is you simply add all these together, and you're going to essentially divide by 42. And as you can see, that's basically what they're showing you down here. In the numerator, that's adding all these numbers and get a total. It's 192, and 42 is the number of observations in the population, and you get 4.57. That's your population mean. Okay, and I wouldn't get too worried about these two definitions. They like to refer to parameter as relating to something about a population, whereas a statistic is a characteristic of a sample. I mean, don't get too caught up in, oh my, I don't know the difference between a parameter and a statistic. At the end of the day, it's not going to matter. So but technically that's what they're trying to show you right here. And in this slide, they're showing you, okay, you have a population mean. What if you had a sample mean? And guys, the calculation is essentially the same, except for, notice this symbol right here, which I like to refer to as X bar. So X bar is referred to as what's called the sample mean. And notice right here, notice that's a lowercase n. Typically, they like to distinguish between a sample and a population. If it's a population, it's going to be a capital N. If it's a sample, it's going to be a lowercase n. Okay, and that's basically all for that one. And as you can see in this example, it's literally the same idea. If this was our sample, there's 12 clients. You simply get a total, add them up, which in this case was 1,170 divided by 12. You get an average of 97.5. That would be X bar. And the median is also known as what they call the midpoint. And so the basic idea is when you calculate a median, you want to always put the data from an ascending order from low to high, and then you got to get the most middle data. And so the couple differences, examples we'll go through in a moment, is what if you had odd number of observations versus even number? That could change the calculation of your median. So you'll notice in this example, notice it's a sample of 5 college students. And once you take this data and down here you put it in ascending order, 19, 20, 21, 22, 25, basically the median is said to be the most middle data. So in this case, it would be 21. So what if you had an even number? So in this case, it's the heights of 4 basketball players. So here's the random data. They put it in ascending order right here. And because it's an even number, what you do is you take the 2 most middle, in this case it's 75 and 76, and you take basically 75 plus 76 and divide that by 2, and you get the median. In this case, it would be 75.5. And yes, sometimes the median could actually be a number that's not actually listed in the actual count, and that could happen. But this is a nice little simple illustration of how you get the median. So guys, the mode is basically the most frequent occurring data. And just so you know, you don't always have to have a mode. Sometimes you might have more than one mode, okay? But basically, it's the most occurring. And in this example, you notice that if you look at all the different, at the frequency charts, it looks like the highest number that was occurring the most was a frequency of 8, guys. And so this distance right here, that would have been the mode. And I do want to mention this because I'm sure you've all calculated your grade point average at some point in time. But there's also what's called a weighted mean. And the weighted mean is basically what happens is you take the set of numbers, which is labeled as x1, 2, 3, and then you multiply those by the corresponding weights. You get a total, and then you basically just divide by the weights. That's called a weighted mean. And then the next slide, I'll show you how that is calculated. So in this case, notice it says that this company pays their employees $16, $15, $19, and $25. So we're going to let those represent XI, or X1, X2, and so forth. And then the weights are going to be basically how many people earn these rates. So if you notice down below, to get a weighted hourly wage rate, what you do is, if there are, in this case, it says there are 26 hourly employees in total, 14, that's the weight, 14 are weighted at this number. Okay, so down here you're taking 14 times 1650. 10 are weighted at 19, so here you're going to take 10 times 19. And then 2 are weighted at 25, so you take 2 times 25, get a total, and then you divide by the sum of, there you are, there's your weights again, right? 14, the 10, and the 2, and you come up with a weighted mean of about $18.11. It's pretty simple. If you follow the ones in the textbook, they're pretty much the same way. But this is how you would do what they call a weighted mean. Okay, and so in the previous slides, they talked about the mean, median, mode. This was basically what they call measures of location. But you also want to look at variability and how does data vary. In this case, they talk about how is the data dispersed. And so in the next couple slides, we're going to get into what they call the range, the variance, and the standard deviation. And the first one, the range, that's one of the most simple calculations. The range is where you take the maximum number, subtract out the minimum number, and you get, it's basically called the range. That one, very simple to do. Could be a little deceiving if you have any extreme data points on either end. So you want to look at more than just 2 data points, because that's really the big weakness with this. You're only looking at 2 numbers. So the one we're going to do mostly is what they call the variance and the standard deviation. And I'll walk you through a couple of them. You have what's called population variance and sample variance. And so the calculations are very similar for each of these, but you'll notice that once you get the variance, and this is consistent, the standard deviation is always defined as the square root of the variance. Okay, so in this example on how to get the range, so here's the list of data down here, 20, 40, 50, 60, 80. The largest number is 80, the smallest number is 20, so the range is 80 minus 20, so the range is said to be 60. Okay, just a couple quick things on the variance. Remember, the nice thing about the variance is that you're going to basically look at all the data and not just 2 data points that the range looks at. Okay, and notice they give you here the definition of the standard deviation. Here's the square root of the variance. But the nice thing here is we're going to observe all observations. Okay, and therefore you're not making any discrimination between the largest and the smallest. You're looking at everything. So it's quite often believed that the variance is a better indication of variability than just by looking at the range. And we'll do two of them. We'll do one for the population and one for the sample. So you notice here's our calculation on what they call the population variance. Notice if you see this symbol right here, I'm going to write this right up there. They like to call that sigma squared. That's what that's going to be, sigma squared. And if you take away the squared, this symbol by itself is just called sigma, basically. You know, X is going to represent your observation. Notice you've got the population mean there. And then notice you're dividing by a capital N. That definitely means population. Okay? And down below, they're going to give you some steps on what you need to do to actually do this calculation. I would always recommend what you do is once you've got the mu number written, is you set up a couple columns. You'll have, for example, x minus mu. You set up one column there. And then the next column, you'll have x minus mu squared. And I think if you do that, it's going to help you do these calculations, and it should simplify the calculation for you. So in this example, the first thing they're showing you is, okay, I need to get the mean. And, you know, if this is my population, they added up all the numbers. They divide, there's 12 months. In this case, it's the n is 12. And in this case, they came up with mu is equal to 29. So once you have that, that's the number you then use in the next step to actually calculate the variance. And notice over here, I mean, the calculation does get a little long on this one, but notice down here, they've got the number of citations listed right here. So they basically, what they did is they basically took this data right here and they put it in a vertical format to make it easier to analyze, okay? And then in this column, I'll just walk you through a couple, it's x minus mu. So if mu is what we say equal to 29, what they would have done is they would have taken 19 minus 29, and that's where they would have come up with that negative 10, okay? The next one, this one, they would have taken 17 minus 29, okay, and they would have gotten a negative 12. That's what they would have come up with right there, okay? So again, the basic idea is you take each one of these minus the mean. Again, just to remind you, the mean is 29. And then notice what you get in this whole column is sometimes you do get negatives. So according to the formula, what you do is you take each one of these numbers, and to get rid of the negatives, you square them. So negative 10 squared would get you to 100. Negative 12 squared would get you to 144, and so forth. You do that for all of these. You then come up with a sum total, which is 1,488. Notice they put that right over there, and you divide that by 12, and you get the answer is 124. So in this case, sigma squared is equal to 124. Okay, that's called your population variance. Now, since I have this up here, the final step, if you wanted to get the population standard deviation, all you'd have to do is on your calculator, take the square root of 124 and you get a certain number. But that's basically would be sigma, which is basically taking the variance and taking the square root of that. Okay, and you can see there's a slight difference in the formula. If you were doing the same thing for a sample, notice instead of mu, they're using x bar. And notice you've got s squared, you don't have sigma squared. And then another difference is, look at the denominator. Instead of dividing by capital N, you divide it by n minus 1. Okay, so if you see this calculation right there, guys, that's going to be what they call s squared, which is your sample variance. But you'll still set up your columns. I'll still suggest that what you should do is you'll have an x minus x bar column. You'll have x minus x bar squared. Okay, so you're going to go essentially through the same process, but there's just a couple slight differences in your calculation when you get to the end. And again, notice in this example, you know, they took your variables, they put them in a vertical format. And let's see, if x bar was equal to 17, so you took these numbers. So to get these numbers, you would take, for example, 12 minus 17 equals negative 5. That's what they would have come up with right there. Okay. If you took 20 minus 17, that would give you 3. That's what they would have got right there. And so what they did is they did that for each one of these. And notice again, you might get a couple negatives. And then the next column, you want to square everything. So negative 5 squared is 25, 3 squared is 9, and so forth. You add them up, you get 40. Okay, so 40 would be your numerator, divided by, well, if your sample size was 5, so 40 divided by 5 minus 1, that's 4, you're going to get 10. So you would say S squared is equal to 10. That's called your sample variance. So if they had asked you then to get the standard deviation, all you'd have to do at that point is simply just take the square root of 10, and that would be your sample standard deviation. And notice in this slide what I said in the previous slide. Here's the actual formula right there. They give you some nice little descriptions on what I just said, but it's basically standard. The standard deviation, whether it's population or sample, it's always going to be the square root of the variance. Guys, I'm not going to test you on Chebyshev's theorem. If you come across it, you can kind of skip that. The reason the authors put it in there is to kind of give you a comparison of how this compares to the empirical rule. But all I'm going to say about this is that you can use it to compare to the empirical rule. But typically the empirical rule is the one that's used most often. But I'm not going to test you in any shape or form. So you can, if you want to, you can just really skip this section if you're not curious about it. And in this slide, they're showing you the empirical rule. And the only thing I'm really going to touch on this one for this particular chapter, we're going to really get into this more in chapter 7, and we'll get into z-scores and at that. But they're just trying to show you that the empirical rule is a bell-shaped curve, and that typically the way that the studies work is based on relative frequency studies. And the idea is that if you look down here, notice you've got this 68%, 95%, and 99.7%. That's going to correspond to what we call z values later on. So for example, we'll say this number is like a -1, that's like a +1. This, where you see 80, that's like a -2, that's going to be like a +2. And then where you see the 70, that's going to be what they call a -3, and that's going to be a +3. And they kind of walk you through that up here. Notice it says approximately 68% of all observations will lie within plus or minus. Notice it says 1 standard deviation of the mean. 95% is plus or minus. Notice where you see the 2, and then the last one is plus or minus 3. And we're going to cover these in more detail later on in chapter 7, but just since this is, they do present it a little bit in chapter 3, they don't really go into a lot of detail. So it's just, read about it, know a little bit about it. I'm not going to test you too heavily, or at least not until we get through the stuff in chapter 7. Okay, and then the last couple things in this particular chapter, one's called the mean of the group data. Notice here's going to be our formula. And notice we've got, again, x bar. There's your sample mean. We've got the Greek symbol sigma to add. F is your frequency. The capital N represents the midpoint. And then we divide by N, which is going to be the number of your observations. And so we'll use this example, and you can just kind of use this hopefully, and then you practice some of their chapter exercises. And also, I think I have one set up in Connect and in your homework to do. But if you can follow this, you should be able to complete it. So if we use this as our base information, so we've got our group data, we already have our frequencies, so then we're going to set up a couple of columns. We're going to have M to figure out the midpoint and so forth, but basically it's just like setting up some extra columns to follow the actual formula, so it's basically like a process. So notice, here we go, so we've got, in the first one, we've got a frequency of 8. To get this midpoint, I already showed you, it's basically 200 plus the 600 divided by 2, so that's going to give you 400, and you basically would do that for each of these. So notice you've got all the midpoints listed, okay? And then once you do that, all you do is you multiply. You take 8 multiplied by 400, gets you to 3,200. You take 11, multiply that by 800, and that's going to get you to 8,800. So all you're doing is you're taking every one of these frequencies and multiplying by their midpoints, and then what you get over here is just you sum 8, you add them all up, you get 333,200. So notice that's going right to your formula in your numerator right there. And because the frequency count is 180, you simply divide by 180, and you get about 1,851. That will be called your sample mean for grouped data. And then finally, you might have to calculate the standard deviation of group data. And notice it's basically, you're using what we just did. We had the frequency, you have the midpoint, and then you have the frequency times the midpoint. But then notice there's 3 more columns. They have midpoint minus x bar, midpoint minus x bar squared, and then the frequencies multiplied by midpoint minus x bar squared as well. So the idea here is x bar, we said, I think x bar, which was the mean of your group data, was like 1,851. That's from the previous slide. So remember, that's the number you're going to use as your x bar right there. So just to kind of show you this number, because in this example, the numbers do get quite large. If we took the midpoint, which was, I believe, 400, if you took 400 and you subtracted 1,851, guys, that's where they're going to get this negative 1,451. For example, on the next one, if you have 800, if you took 800 and you subtracted 1,851, you're going to get about a negative 1,051. Okay, so again, just to show you that they're taking each of these midpoints, they're subtracting out that group data mean, which was about 1,851. And notice they kind of rounded it off, and I'm just kind of doing that here just to kind of give you the basic idea. Once you do that, you square it in this column, and then you take whatever you come up with in this column, you have to go back and multiply by these frequencies again. That's what they're doing here. And then they get a total, okay? They then take that total, which they're kind of showing you the formula right down here, that total divided by 180 minus 1, and they're doing the square root of that, and they get this number right down there. That would be your standard deviation of group data.